Welcome to Mission APSC as a YouTube channel. We are discussing about the effective state and quicksand condition. In this video, we'll discuss about the Seepage analysis. Seepage analysis is another important topics for APSC, assistant engineer and junior engineer exam. So today we'll discuss about seepage pressure, how the seepage pressure created, all details about seepage pressure, and we'll try to finish this topic today. যদি আপোনালোকে চেনেলটো নতুনকৈ আহিছে দেন চেনেলটো প্লিজ লাইক শ্বেয়াৰ এণ্ড ছাবস্ক্ৰাইব কৰি দিব কাৰণ এই চেনেলটোৰ যোগেদি চিভিল ইঞ্জিনিয়াৰিং ৰিলেটেড যিবিলাক টপিকছ হয় যিবিলাক APSC সোধে চ' তেনেকুৱা ধৰণৰ কুৱেশ্যনছবিলাক আমি ডিছকাছ কৰোঁ চ' উইল মুভ টু টুডে দ্য চিপিএছ slide. Before that, well, if you don't watch my effective stress video, then please do watch. This is the basic introduction. After that, please continue this video. So I'll put the link of effective stress video in the description box. So here we'll try to discuss about these are the effective stress slide, and we also discuss the quicksand condition and boiling. Then we also discuss about the quicksand derivation, that is z minus 1 1 plus I, which is critical gradient. This formula is important. Then we also say that quicksand is not a type of sand. Several numbers বহুতবাৰ MCQ সুধিছে quicksand condition to কোনটো soilৰ ক্ষেত্ৰত হয় ওকে বা কেতিয়াবা সুধি দিয়ে quicksand condition to gravelৰ কাৰণে exist কৰে নে নহয় মনত ৰাখিব quicksand condition is not applicable for gravel because gravelৰ ক্ষেত্ৰত the hydraulic gradient, the value of hydraulic gradient is very good, is always stands to unity, right? So সেইকাৰণে gravelৰ ক্ষেত্ৰত quicksand condition arise নহয়. Try to remember. Okay, so today we'll discuss about the seepage. So see, seepage is basically the flow of water, right? So here if you see this figure, suppose here the pani tepere pani goi ase, right? Suppose it is the length of flow and this is the height. So here we can see the figures of the terms, right? So suppose our elevation difference ase, suppose here pressure head to amar ase ace, this particular value is ZA, that is elevation head, and after that this is the pressure head. Because of pressure head difference, the water flow from that high elevation to lower elevation, right? And the loss which is encountered, that loss is known as head loss or the head difference or energy loss, right? This is the elevation head, this is the pressure head, this is the total head. Total head কেতিয়াবা সুধি দিয়ে MCQ, total head is the summation of elevation head plus pressure head, right? Then we'll move to the next slide. See, in case of two-dimensional flow, যদি আমি two-dimensional flow হিসাবে flow to discuss কৰো, then we'll get suppose this is a impervious boundaries, this is a impervious boundaries, okay? Then these are the delays. It is the head difference. Basically the liquid will flow from the upper stream to downstream, right? So we have one formula of Laplace continuity. In reality, the flow of water through soil is not one direction. Okay, Laplace equation of continuity ki koise the flow of water through the soil is not one dimensional, nor is uniform over the entire area of perpendicular to the flow. But Laplace equation e koise ki they assume kori loise that flow of water is in two-dimensional is described using Laplace equations, right? Laplace equation is a combination of the equations of continuity and the Darcy's law. So Darcy's law aru continuity equations for combination kori pelai Laplace law to form kora hoise. So Laplace law pora will get this particular expression. Try to remember this expression, okay? That is basically the Laplace equation of continuity. So from here for anisotropic soil or for isotopic soil, we get one particular Laplace equation. This Laplace equation is valid for isotropic soil, right? Now the question arises, what is isotropic soil? Isotropic soil means, suppose this is a soil element, it has a permeability in y direction, it also have a permeability in x direction, kx, right? So now this is the permeability in x direction and y direction. If the permeability of x direction is equal to permeability of y direction, then it is known as isotropic, right? So isotropicৰ ক্ষেত্ৰত Laplace equation to হৈ যাব del square a del x square del square is del z square equal to 0. Then we'll move to the next part. What is flow net? Flow nets are the graphical solution of the method of Laplace equation for 2D flow in a homogeneous isotropic aquifer. In an isotropic medium, the continuity equation represents two orthogonal families of curves. So flow lines, the lines along which the water particles will travel from upstream to downstream side in a permeable soil medium is known as flow lines. This is the flow lines. Flow line basically the line where the soil is flow or where the water is flow inside the soil. This line is nothing but this blue color line is basically the flow line. An equipotential line is the line along which the potential pressure head is also equal. This is the line which is drawn like this. This is nothing but equipotential line. So what do you mean by flow net? Flow net is basically the combination of flow lines and the equipotential line. Okay, to complete the graphical construction of a flow net, one must draw the flow line equipotential line in such a way that equipotential lines intersect the flow lines at right angles. The flow elements are approximately in square. Okay, so if you see the equipotential line, this is the equipotential line and these are the flow lines where the actually the flow is taking place. That lines is nothing but flow lines. So the intersection between two flow lines and two equipotential lines, let me change my color so that it will clear to you. So the this particular part, the interaction between two flow lines and two equipotential line is known as flow lines. And remember the angle between this angle, the angle between the flow lines and the equipotential line is 90 degree. Why this flow net is useful? This flow net used to analyze the flow. Okay, so then NF is basically the number of flow channel in a flow net and ND is the number of equipotential drops. Okay, so how to construct the flow net drawing techniques? Draw the convenient scale and geometry of the problem, establish the constant head, no flow boundary condition and draw flow and equipotential lines near the boundaries. So there are several rules for constructing the equipotential lines. Okay, then this part is not important. Okay, so seepage calculation we can sometimes in APSC they ask about the flow channel. What is flow channel? Flow channel is basically the strip between any two adjacent flow line is called a flow channel. The drop of the total head between any two adjacent equipotential line is called potential drop. Okay, so then this expression is important. Del Q is equal to K is NF ND, where NF is number of flow lines and ND is the number of equipotence. NF is basically the number of flow lines and ND is the number of equipotential drop. So we'll try to discuss some examples for the flow net and this part will be discussed in the later classes. Thank you for watching.